Okay, welcome again. Now I'm going to do questions 6 and 7 in quick succession now. So question 6 is the question about the Formula cars, Formula One cars, and they're racing towards the finish line. So let's put them on a track. Here's the finish line over here. So there's our two cars moving there, and we'll put the other car here. The velocity of car 1 relative to the ground is 350. So this is car 1. So let's put car 1 there. And this velocity is 315 kilometers per hour. And the car 2 is 319 kilometers per hour. That's car 2. Okay. Now, our question is, what is the velocity of car 2? So the velocity of 2 relative to 1. So if it's a question which simply says, what is this relative to this, use this symbol, velocity of car 2 relative to 1, and then you know it's velocity of car 2 minus velocity of car 1. And that makes it so much easier when you just use the language of the question to work with you. Okay, and these are vectors, so it could be all in different directions. So, velocity of car 2, let's make this towards the east. This is the finishing line. Okay, so we'll just say that this is the positive direction and this will be the negative direction. So it'll be car 2 would be 319 minus car 1. Now, car 1 is still going towards the positive, so it's minus positive 315, and that will be 319 minus 315, and that's 4 kilometers per hour. So if you were sitting in car 2, you would see if you were sitting on in car 1, you would see car 2 move away from you at 4 kilometers per hour. In other words, if you pretend that you were stationary and everything is stationary, all that you would see is car 2 move forward at 4 kilometers per hour. If we did the opposite direction, we would have got minus 4 kilometers per hour. In other words, if you were in car 2, you would see car 1 move backward if you considered yourself to be stationary. So that's question 6. Question 7, Alyssa is running across a soccer field at 6 meters per second, and she's doing it in the north, so that's 6 meters per second, and that's her. She then kicks a soccer ball to another player and continues running with the same velocity. The ball travels at 20 meters per second east, so the ball is going at 20 meters per second east. Okay. Calculate the velocity of Elsa relative to the ball. Okay, so this is the velocity of Elsa, this is the velocity of the ball, and we want the velocity of Elsa relative to the ball. Okay, which would be the velocity of Elsa minus the velocity of the ball. Okay, so because these are not in cardinal directions, so I'll just move that up a bit, we're just simply going to draw them as in vectors over here. So this one here is velocity of Elsa is that with a 6, and minus this, the ball vector, which is 20 that way. The negative of this vector would be adding these two together with the opposite direction, so that would be a 6 plus a 20 in this direction. Okay, so adding them up here, I'll just do it above it because I'm running out of paper. So that's 20 plus 6. So therefore, this would be the velocity of Elsa relative to the ball, which is, using Pythagoras, V would equal 6 squared plus 20 squared, all square rooted. And let's have a look what that would equal. So that's 6 squared plus 20 squared. square root of the answer, 20.88. So let's just take 21 meters per second. Oops, I've run out of space on this video here. Okay. And if you want to calculate the angle, you can calculate the angle there just using tan. Okay. Thanks very much.